Hello and welcome everyone. This is a webinar on how to develop, deploy, manage, and update secure IoT and Edge devices. I'm Tyler Baker. I'm the Chief Technology Officer at Foundries, and Tal Simo's joining me here. He's the Managing Director of Sales and Marketing for the Americas at Variscite.
Hi everyone.
So let's get into it here. So our agenda, we're going to just do a brief overview of what we're going to talk about. So we're going to do an introduction to Variscite and Foundries. We're then going to talk about the benefits of adopting a DevOps methodology for embedded development. And then we're going to talk about the challenges of IoT and Edge product maintenance. That'll lead us into a discussion about best practices for deploying secure OTA updates on these products. And then we're going to do an introduction into Foundries Factory and then actually show you a live demo. So that's just a brief overview of how this webinar is going to be run. And yeah, that kind of gives you a quick look into what the content is going to be. So I'll let Tal take over here, and he'll talk about Variscite.
Hi everyone. Welcome to our webinar today. Just a quick overview about Varisite. Okay, so you know what you are meeting today. So today Varisite is the first ARM-based SOM vendor, and we are selling more than 2 million SOMs per year. Almost 20 years in business with a very wide customer base for 6,000 customers and growing. Today we're also the most diverse i.MX-based product portfolio. We are a platinum partner of NXP, and we have our own internal production, which is today with the worldwide component shortage, it's very critical, of capacity of more than 3.5 million SOMs per year. And of course, we have a very large ecosystem of partners, so we can give a quick, complete end-to-end solution, and Foundries and what we're doing today is part of this ecosystem. Of course, Varisite is also certified with all the ISO, including the medical ISO as well. Next slide, Tyler. So I assume most of you know that, but let's review it quickly and what Varisite system module actually provides today. So of course, fast time to market. Okay, you don't need to invest a lot in development here. Of course, the reduce of R&D costs. We provide a scalable and upgradable system. Okay, scalable, we have a pin-to-pin family, and upgradable, we allow you can actually customize your SOM with different customization and define only the features you need. We are doing a lot of internal testing, including 100% testing for all our SOMs. So actually, what goes out of our factory is 100% yield all the time, which is very critical. All our hardware and software is ready to use, and of course about reliability and low risk. You know, our platform has been tested by hundreds of customers. Okay, so what you get is already proven in the field. We provide a free support for with our customer portal, our wiki pages, drawing, and GitHub. Everything is fully open and free. And discuss very stable in-house production line that will help us keep a very stable lead times. And we put focus on our product longevity and try to give all our SOMs up to 15 years of longevity. Next slide. And just a quick review of the advantage. We talk about the scalability options. You see our main two pin-to-pin families. One is the VarSOM, which is the upper one. It's an edge connector, SOD edge connector, and you can go out from the low level single core 6UL up to the high-end i.MX 8 and i.MX 8M plus as well. Okay, so a lot of flexibility. You can actually use the same hardware. These SOMs are pin-to-pin compatible. You can actually upgrade without doing a lot of effort, and this is great. And then we have the Dart family, which is a board-to-board connector, and it's a smaller pin-to-pin family, mainly focused for small size, and we have a size limitation products. So this is how we give a lot of flexibility to our customers. Thanks, Tyler.
Great, thank you, Tal. So I want to quickly talk about Foundries.io. I'm sure you're all very familiar with Variscite, so just a little introduction about our company. So in 2017, we founded Foundries.io. We actually spun out of Lenara, which is the open source ARM division, working on ARM SoCs. And then in 2019, we spent 2 years there working on our product, which is Foundries Factory, and it's a cloud-hosted, fully managed DevOps product to build, test, and deploy updatable IoT and Edge products. And that was really our vision there. And so then we spent that year in 2019 to 2020, ramping up customers and getting the ecosystem on board. So, making sure we have templates available for all the common ARM processors and Intel machines out there, RISC-V, all the different SoCs available. So, from 2020 to 2021, obviously the world changed a little bit, and everybody needed, distributed development software tools, and we kind of started to take off. So we have, a 1 million unit project deployed. Global Fortune 500 companies that are deploying on Foundries Factory, managing their devices, and we have over 25 SoCs or SOMs from different device manufacturers ready to go in a turnkey manner. And now on to 2022, we're looking to push that out further and start to have even more ramp on our product. So that's just a quick background of where we are with Foundries and where we've come from. And now I want to talk about the IoT product challenges. I think everybody in the industry, in some form faces these. So the first one is obviously expertise for firmware, OS, and product development. Everybody knows when you want to build an embedded product, depending on the SoC that you choose, the software will be different, and you need to have expertise to do all of those pieces, from the boot ROM forward to then the kernel that gets booted, and then the actual distribution that you're going to use before you start actually building, the end use case of your product. So it's his work that we all have to do, but not necessarily differentiating when it comes to a product that you're building. We also then need to enable and maintain secure devices, or at least that's where the industry is heading. I think traditionally we've kind of had taken a lax approach to security on embedded devices, and I think that industry is changing now. And so that's something that we focus on. And it also, when you look at a project schedule, usually gets put at the end of a project schedule. And we know about project schedules is they seem to get compressed, and then they have to make trade-offs on security. We've seen it time and time again in the market where, folks leave their keys on the file system, and they're available if the attacker gets remote access. So things like that are kind of pushed to the end and get forgotten. We all know that increasing technical debt and long-term maintenance costs are expensive. I worked for various product companies throughout my career, and I worked on sustaining teams, where we'd sustain products for 20 years, and it was very difficult to build that old software again, fix the bugs that were in that software for a customer, and have to have that ready to go even 20 years later. So those are costs that are associated with maintaining these products that we're going to see in the next 20 years. So I guess the next question here is, well, how do we solve these problems? So what we believe we've created is a SaaS product. So it's a fully managed cloud service called Foundries Factory. It is a complete end-to-end solution, meaning it gives you all the tools you need to build a secure, updatable, embedded, or edge product on the internet. So cloud hosted by us at Foundries. Now, why is this important? Well, if you think about a project schedule, you have to have all of these different team scheduling. So your CI team and your platform team and your applications team and your marketing team all have to be in sync and have to deliver so that the project doesn't get delayed. The problem with that is all of this can be done in a single place, and we don't have to have those delays of, okay, well, now we have to figure out how to build the operating system, produce the binaries, figure out how the signing works, then we need to figure out how security works, and we have all of these meetings, and it takes really, really long to build products. So what we wanted to do is take all of our knowledge of building products in the real world and create a service that helps you do all of this and makes it very easy so that you can get to the point where you're adding value to your product and you're reducing your costs, you're reducing your risk of getting that product out to the market, and you're becoming more efficient. So what we provide here is we provide the boot firmware and the root of trust provisioning as a template, meaning we have customers just like Varisite, where they've proven their SOMs in production with customers. We've done the same with the software platform already. So this is something that you can inherit and leverage rather than build yourself. We also provide the firmware, the kernel, and the distribution, and any container technology that you choose to use. So this is all built into the platform, and we're going to get into this in the demo. So don't worry about not understanding what this means right now. We also provide pre-configured CI/CD pipelines that deliver the operating system builds and any container builds or firmware builds that you may need. We also provide a secure OTA update. We use a framework called TUF, which stands for The Update Framework. It was developed by the Department of Defense here in the United States to resist nation-state attacks. So companies like Amazon, Google use this to develop or to deploy their software, but usually just application software. We've taken it and modified it to work with platform software and containers. We also offer device management and fleet management. So all of this kind of bundling together all the tools that you need to manage your product in one place. We are, again, cloud agnostic. If you want to use Azure, AWS, Google, whoever it is, maybe you have your own cloud, we are very API driven, and we kind of are very flexible with our customers. They can use whatever cloud they'd like to use, and we stay out of it. And we put all these tools together as a SaaS, so software as a service, and it's a per project subscription model. And we'll get into what that means here in a second. But the takeaway is this Foundries Factory is a complete software lifecycle management solution from development to manufacturing to production. We cover all of that and kind of fast track you to get to market quickly. Oops. So Varisite and Foundries Factory. So how does this work, and why is this good to use together? Well, you can be minutes away. So if you've already chosen the Varisite hardware, you could be minutes away from a configured Linux platform that is effectively a palette for you to start to develop your product. Again, complete end-to-end solution. We don't have any software fragmentation. So we actually maintain the distribution in the open, and then the distribution that is customized by the customers in the factory. And you'll kind of see this in the demo of some of the customizations that you can make. But if you need to patch the bootloader or ATF firmware or the kernel or the distribution, you're having that ability to do so. So you have full control over the system, but you don't have to do the distribution maintenance. And so there's less software fragmentation. The other part is we have security designed in. Now, people say security, what does that mean? We have root of trust provisioning. So from the boot ROM forward, we have a root of trust established that can either be done with the SoC features that are there with the replay protected memory block, which we'll talk about in a moment, or if you have a discrete hardware security element, we also have integrations for that. So it's turnkey. You don't have to think about how to implement that yourself. We've already done that. It's in the open, so you can see it and you can audit what we're doing, and basically you can turn it on as you're starting to go into manufacturing. So you can start your development now and not have to worry about that and turn it on later. We also offer long-term support. So like Varisite, they offer longevity, for 15 years. We also mirror that as well. So we are going to support the software for you as a customer for 15 years, and you'll get that long-term support, and you don't have to worry about your internal teams having to do that. So I think there's a lot of value in this offering together with Varisite. They can get you to market quicker. They have a very robust SOM, and we kind of mirror that on the software side, where we have a turnkey template that can literally be up and running in an hour, and you're ready to start developing your end use case. So together, we eliminate your IoT product development challenges and reduce costs, and we also reduce your risk in the schedule. So what's the business model? You're probably asking yourself. So Enterprise Edition is $50,000 a year or $5K a month. Now, this is a SaaS, so you get access to all the tools that I talked about, plus customization and support. We're going to offer you a quick start with the Varsom MX8 Mini, product lifetime support and maintenance updates as well. There's no per-device royalty, transaction fee, or any metered fees. This is a fixed cost subscription. There's no business model or technology lock-in. We base all of our technology on open source software and open specifications. So if you don't like what you got, you have all the source code to everything that you're interacting with, and anything that you're interacting with on our back end is an open protocol, and there are other options out there for you to go use if you don't like the service. So there is no lock-in effectively. And what our business proposal is here is that Foundries Factory is a fraction of the cost of a single expert engineer, right? So to even build up the teams needed to provide all these services, you probably all know it's very costly. You can do this now at a fraction of the cost. And what we do is we amortize that cost over all of our customer base, which then gives us more of a robust solution, but also enables us to kind of be disruptive in this market. So if you're interested in other Varisite platforms beyond the MX8, it's very easy for us to enable. Just come and talk to us. What you'll see at the end of the demo here is you're going to have an opportunity to try this out yourself for free for 30 days. We'll get into that in a moment here. I'm going to hand this back over to Tal. He's going to kind of describe this hardware, and then we'll continue on. Thank you.
Yeah, thanks, Tyler. So just to give you a quick overview of the platform that we are going to review the demo today, that Tyler will take us to the demo. So this is Varsom MX8M Mini. This is today one of our high runners. It's actually based on NXP i.MX8M Mini processor. It's a quad-core, up to quad-core 1.8 gigahertz, and also a core processor, real-time M4 400 gigahertz. It supports a lot of features. If it's a USB 2, gigabyte Ethernet, PCIe connection, you can actually select up to 4 gigabyte RAM and up to 64 gigabyte eMMC. It has great GPU and video encode decode capabilities as well. And we also provide an option, a single or dual band Wi-Fi, certified Wi-Fi and Bluetooth on this model. This platform can go up to industrial temperature minus 40 to 85 degrees Celsius. And of course, it's a member of our pin-to-pin family, so option to upgrade or downgrade is always available. And this platform also has up to 15 years of longevity. Okay, so one of our main high runners, and that's why we said that it's platform for the demo today. So Tyler, please take us through the demo.
Great, thanks, Tal. So now we're going to get into the live demo. And a lot of our customers like to describe their experience with the factory as magic. So we're going to show you the magic right now and hopefully show you that there's no magic underneath it. It's just a well-integrated solution. So let's jump into it. So what I want to quickly show you is our quick start guide. This is going to be provided, a link to this will be provided in the slides, but I really want to show you that everything that I'm going to demo today is exactly what you can reproduce yourself if you want to for free. So what the first step is here is you're going to go and create a factory, and you can do so here. So we have the MX8 Mini, and then you can give it a name. So T Baker Testing 05, and we create a factory, and it's that simple. So if we can go to this factory, it's going to start up. It takes a little bit to provision and get the builds going, but we'll kind of check back in on this factory as we do a demo. So I've already created a factory. I've registered a board, and we're going to go through what we can do with it. But I just wanted to show you how easy it is to get started and how little time it takes. So that was directly from our quick start guide, and that you'll be able to do that at the end of this webinar. So I've created another factory already. I've registered a device. This is a Foundries Factory. So this is kind of the overview page that gives you some information about how many devices you have, tags we'll get into a moment, what the name of the factory is, and you can see this is a partner factory, so it has all the great Variscite enablement already contained in it. Now, at the core, what the real core piece of a factory is creating targets. Now, targets are a tough term. So again, the update framework specification that is basically an abstraction for a secure OTA update. Now, in our case, targets may be platform targets, meaning operating system firmware builds, distribution builds, or container builds. Now, the targets will kind of link together. So if we take a look at maybe the first target here, it's a platform build. It's built for a specific target, which is the Symphony board here, the MX8 Mini, and it's for AR64, and we have an OS tree hash. Now I'll get into kind of how our update system works, but this is a representation of an OTA update with actual build and binary artifacts completed in it. So within a target, it is a fully immutable, atomic, and auditable update, meaning that the only way a target gets created is from pushes to the Git repositories which are hosted. So within a factory, you get a build system, you get device management, you get manufacturing flow and tooling, you get a production flow, you have team management, and you have source code. And this is all private to your factory. So it's a sandbox area for you to do your development. And what happens is you push code to these repositories, they create targets, and these targets are represented here. So it's a kind of a core concept. I want to make sure I explain that well before we move on. And so what you get out of here is an OS tree hash. Now we use OS tree through TUF to apply incremental platform updates, meaning that only what you've changed on the platform will be calculated as a delta and then be delivered as a layer effectively with OS tree down to that device. Now what that allows us to do is it's almost like Git for your file system, meaning that we can just layer up the root file system changes, and if we need to roll back, we can simply go to the last known OS tree hash. So it's a very, very simple process. It allows you to use the full flash size on the product that you're using without any compromise of doing like an A/B update or things like that. So it's a very bandwidth efficient update system as well. Now let's take a look at what you actually get out of one of these targets. So on a platform target, you have access to a whole lot of things here. So you have the console log. So we built Yocto, and if you've ever built Yocto, it's kind of a pain, right? A lot of dependencies to get it going. We take care of all that problem. We have cached builds from the get-go, and it takes about 20 minutes to build in the cloud for us. And I mean, you have access to all the logs and live logs as it's running. But I just wanted to point out that you have that ability to kind of see how everything is being built. We also pin each of the manifests. So each build is absolutely 100% reproducible in the cloud or locally. So if you want to try this build out locally, exactly how it's built in the cloud, you can download our simulator and run it, and you will get the exact same output from a binary standpoint. So here's your artifacts. These are your actual flashable artifacts. These are your pre-built binaries, if you will, of all the boot firmware, the root file system image, and any of the other bits that you need to actually boot the platform. You also have a lot of access to so much more than that. You have opt-to-e binaries, you have device tree blobs, and you have the source files as well that are included here. You have license compliance files, so if you need to know about what open source licenses are in this build, that's provided as well. And you get kernel configuration, U-boot configuration, all the stuff you need as an embedded developer to actually figure out what got built. Along with that, you get manufacturing tools. These are the tools that you use to provision the board, to set the root of trust, to go through the manufacturing process. That, again, is built as well and provided to you. You'll also get a reason why this target was built, and it's down here, so it's all traceable through the Git repositories. So that's quickly just a platform target. The other kind of target that we have is a container target. And this is where we can build containerized applications that we can then orchestrate on top of our platform that we've created. And so this is a simple example, again, all traceable through source code. It also lists the target. So there's a platform component of this target, and then there's an a application component of this target. Again, we pin everything. So if you're familiar with Docker, there's an idea of tags. A lot of people use the latest tag, or they have a name. The problem with that is that tag can be updated on the back-end side while you're doing a rollout, which means you have half your fleet running a different version of the software, even though the tag is the same, and we don't want that ever. So what we do is we actually pin the SHA-256 hash of the image that we want to deploy, and that is in the manifest now, or in this target. You also get all access to all the logs of how the container was built. We actually take care of building it natively for you, so we don't cross-compile containers or any of that nonsense. This is native builds on 32-bit ARM, 64-bit ARM, or 64-bit x86 platforms. And again, you get a reason why the build was triggered. So the one takeaway from a target is this is this cryptographically signed manifest, and I don't want to get into the technology about how tough works. We can go read about that later. But effectively, it's a signed piece of metadata that the device will pull down. It will read, it will verify the signature on that metadata, and then it has all the hashes of things that it needs to update to, and that's what's going to execute and update when we provide it updates. So that is the kind of core functionality of a target. I'm going to leave it at that. There's lots to go on there, and we have lots of documentation if you want to dive in. But please ask questions in the chat if you have any. I'll address it after the demo here. So let's look at device management. So I have one device registered here. To me, it tells me that I'm on target 4. And again, there's traceability in this. So if we go back and look at target 4, we know we're on this target here. So if we look at the device details, we get the hash that we're on currently. Is it a production device? We get all this great rich data. We also have a way of looking at the update history to see which updates it's taken. We also have a secure configuration system, which we're actually going to demo here in just a moment on live hardware. This allows you to make changes to the device configuration at a device-specific level. So if you need, specific files shuffled to that device, you can do that. If you need to deploy those files to the entire fleet of devices, that's available as well to you. So that's a configuration set up there. You also get IP address information, some hardware info, and the device's public key. So all of that is what you'll get when you register a device. We have a fleet rollout feature here, which is waves. So if you want to create, a fleet rollout where you target 1% of your devices in production, you can do that as well. So that's kind of just the device management side of things once you've created targets. And then you can add team members. So you can add folks here by email address and assign them into teams. So if you want to limit access to what source code they have or what functionalities of the factory that they're able to access, you can do that as well. You can create teams as you need to now. So really what a factory is a collaboration tool for building embedded software devices that are secure. Now we can take a look at the source code. Before that, let's actually run through a demo here on hardware. So I'm going to switch my screens, and I'll give you a quick overview of what you're about to see here. So right lower corner, this is the Varisite MX8 SOM. This is exactly what Tal introduced a couple slides ago. And then in the upper right-hand corner here, we have the serial console for that board. So let's go ahead and boot it up, get it connected to the internet, and we will start to make some changes to it. Okay. So we're all booted up now. Let's jump in as soon as it connects to the internet. There we go. And we'll jump in on this terminal here. So what we'll do for this demo is show you the logs as we do this update, so you can kind of see it. Because when you do an over-the-air update, a lot of times it's kind of hard to see. So on this bottom right-hand side, I guess the middle screen here is our actualizer light daemon. Now, this is the update daemon that's going to do the secure updating. And on the left side, here's our configuration daemon. So I'm going to make a configuration change to this device. I'm going to deploy that containerized application, and then we'll actually watch the whole process happen. Now, this containerized application is a Chromium browser with all the OpenGL extensions for the i.MX 8. So we're going to actually use the GPU inside of a container, and we're going to show a website which has all of this great fish tank demo on it. So we're going to go ahead and do that. Now, before I get into that, I want to show you our tool that we use to manage our factory. So everything that you saw in the web UI, you can do with our tool Fioctal. And again, Fioctal is a tool that uses our API. So if you want to write your own tool, or you want to integrate with an existing cloud, the API is available to every user in the factory with a token. But this is just an implementation of it. So I can do a Fioctal devices list. I give my factory name, and it lists my devices, and it tells me some status about my devices. Now, what we can do is we can build this command line up. And again, this is all in that quick start guide. So don't worry about writing any of this down. You won't need to know it. It's all in there. So what we're going to do is we're going to make a configuration update. I'm going to target a specific device, T-Baker testing 0401, in my factory, and tags. We'll get to this in a moment, but this is an interesting one. We're going to stay on the master branch, and then we're going to add the app tank. So this is the Chromium browser that's going to have a fish tank deployed on it. So I'm going to go ahead and hit enter here, and oops, did I screw the thing up? Sorry. There we go. Okay, so now the configuration here down here on the left-hand side has been pushed to the device, and it's fetching the application that we have in that target. Once it's pulled down, it's going to use a we should see the fish tank come up here on our compose spec to actually orchestrate that container on the right-hand side once it's deployed. At this point, what we'll do is we'll kind of interact with it a little bit and begin to kind of show what it can do, and then we'll remove the app as well, just so that you can control it. So right now, here's our fish tank app. We have a single fish swimming in there, not so fun. Maybe we'll add a few more fishes. Now we have 10, and now we have 100 fishes, if I can tap that properly. Yep, there we go. So we can have a lot more fishes, and then if you're sharks, that's your thing, we can put some sharks in there. If I can touch that properly, there we go. There's a whole bunch of, there's 1,000 fish with sharks with laser beams. There's a demo. So you can kind of see that you can build accelerated applications, very easily deploy them, and I'll show you how easy it is to actually remove those applications. So we're going to do the same command line, except we're going to just insert a comma, which is going to tell our system to remove all the apps from the system, and we're going to push that down. You'll see the configuration change here on the left side, and now we're going to remove this application. And once it's removed, we should go back to our X-Wayland home screen with our logo there, and then I'll show you kind of a little bit about the source code. Okay, great. Now the application's removed. We've done our first successful over-the-air update of a containerized application. That's easy peasy. What about the platform stuff? You're probably asking. Well, let's take a look at how this works. So quickly, I just want to show what we've done on the Xkiosk application. So this is the compose file. And I'll go into plain text mode so you can see. This is exactly Docker Compose. So if you're familiar with that and you've used that before, this should be no problem at all to get going. Very, very flexible, and it's a standard that is used widely across the industry, so we haven't done anything special here. Now you can see we're mounting some stuff, like we've got the Galcore driver that's being put in there. We have C groups rules, excuse me, as well to provide proper access into this container so that it can utilize the GPU. So that's kind of how we're building those containers. Again, this is all hosted. It's all private. It's easy for you to do. Now, I want to show you quickly an over-the-air update for the platform side, as that's probably something that you're interested in. So I mentioned that my device was on master. We have this idea of tags, and tags can follow branches. And so we have a branch called Devil. You get this by default when you start a factory up. And I've made a single commit and pushed it. It is adding strace to the image. So it's a debugging tool that I may want to have on my platform at some point. Now, this could be any other native application or recipe for Yocto that you'd like. Okay, so, and you can see the reason is add strace to the image. So what does that look like? Let's do the same thing here. So all we're going to change is this devil tag. Now this is going to do a complete over-the-air update. So what you'll see here on the console side is that this device is going to reboot and apply this update. So let's go ahead and try that. Should probably show you that strace doesn't exist on this image first. Yep, it's not found. So now it's fetching the OS tree commits. It's pulling down the deltas. So it's just the strace configuration. And then we're going to go ahead and reboot the platform automatically. Now again, our customers, they have access to how to control the update daemon, so it won't just reboot on them. Their command and control application will be able to modify that behavior and schedule the update when it makes sense for that device. So there's a lot of flexibility on how you take updates and when devices take updates, etc. Okay, so we did our platform over the air update. Let's see if the network connection's back on yet. I'm just gonna wait for it to connect to Wi-Fi. Okay, and we're back on Wi-Fi, and let's see if we got strace there. Oops, did I spell it right? Oops, I don't think that worked here. Okay, so that was the platform update. You've seen that there. Now I want to kind of go back to the slides a little bit. Let's go back into present mode. So if you want to try anything that you just saw today with the MX8 mini hardware, it's available. We have a quick start guide that we're going to put into the slide deck and distribute to all the folks that are on this call right now. It's free, again, to create an account, to flash a board, build an operating system. You can make platform level changes. You can add patches. You can manage your devices. You can try the full thing out. And again, just you can click on these links and it'll take you to that same exact link that I created at Foundries Factory. In fact, what we can do real quick is just look and see how that's going. And so what you'll see is it's actually building all of the targets for you right now, at least the initial one. So if you actually click on the live log here, you can see it building in real time. And so that's what you would expect, right? When you start a factory, it's going to build everything for the first time, create that cache for you, and then all the other subsequent builds are going to be very, very fast. So let's get back into this. I guess at this point we can stop and see if there was any questions during the demo or the presentation, and I guess I'll open that up to Tal and see if he has anything for me.
Currently, no. No questions. Okay. Looks like a very detailed and good demo.
Excellent. Okay, so if you're interested in contacting us, again, we're going to distribute the slide deck, so you'll have all these links, but we have our website, documentation, YouTube, GitHub, email, and a 30-day free trial link as well for Foundries. And if you're interested in contacting Variscite, all of their information is here for their website, email, customer portal, wiki, and GitHub as well. So thank you so much for this webinar. I hope it was interesting. I hope the live demo was interesting and will inspire you to give it a try if you have the hardware. I think it's a really good solution, and you can see how fast it will accelerate you getting to building your product in that end use case. So thank you very much. I appreciate the time.
Yeah, thank you very much, everyone. Have a great rest of the day.